energy of water heating. So basically we were at zero solar thermal and 10 megawatt solar PV at the baseline in 2010. There's been a number of projects under this mission to grow that up to the 150 plus 500 in this first phase. And you can see that growing up over the next couple of years up to 20,000 and 2,000 being 20 million solar collectors by the time we get up to 2012. So 20 million solar collectors is a lot of collectors. Where the advantages for hot dip galvanizing is those that are located on the ground. If we start looking at rooftop solar collectors, we are really battling aluminum. It's lighter, it's softer, it's easier to cut. So the installation of rooftop solar collectors, we have a very tough fight with the aluminum extrusions industry. But for everything on the ground, we should really own that in hot dip galvanizing. So a great many of those solar collectors are of course on the ground, and that is a market we should just own. And the market potential for these 20 millions is quite a few million tons, of course. So that's the first part of my presentation on the market trends. We'll now turn to the technology trends. So we're going to be talking about one of the things I mentioned before, which was lighter, stronger, cheaper, and that leads to several implications for technology. We'll talk about some recent design information which has come up on the K-joints and also fatigue. We'll talk about galvanized rebar, and finally an issue about old zinc or zinc quality. What we see with the development of steel is that we are moving from steels where the source of the strength is alloying to steels where the source of the strength is the heat treatments or the transformations. So this is allowing cheaper, leaner steels to be used. In the past years, we've depended upon the alloying additions like molybdenum and chromium and other more expensive elements to provide the strengthening to steels, and these were cooled at slower rates. The availability now of faster cooling was mentioned in Mr. Venugopalan's talk, the first thing about the rapid cooling rates, and this is also true for galvanized structural steels. So this shows an example of several processes. In the old days, the hot rolling on the left side was hot rolled and then slowly cooled. The next one is the controlled rolling, where you are doing a rolling and then cooling before and after the rolling, and coming up with a much finer microstructure, as you see here. But the most recent one is the QST process, which has been trademarked as High Star by one of the producers, where you are water cooling and then we are producing a thick plate of a much leaner composition, which means it's a cheaper steel by using a heat treatment process, which is much more similar to that used with steel sheet these days. So we're seeing the pickup or the transfer over of the manufacturing techniques from the flat product over to the plate and the shaped products here. So this shows the sorts of things that are involved metallurgically. We won't spend any time on this, just to show that the different cooling rates we get, which are these diagonal temperature versus time lines, as you cool down with different cooling rates, you end up in different metallurgical phases with different strengths. And so by controlling our cooling rate, we can end up with a wide variety of metallurgical structures. And this is one of the beautiful things about steel, is that you've such a wide range of endpoints for processing here with these different cooling rates. But not only that, but you've got a wide range of elements you could put in. So this is even a more complicated slide showing the time temperature graph again. But this just shows you, and I just want to point out here the potential that we really are just getting started on this. So we have a very, very long way to go before we take full advantage of everything we show in this chart, with the changing of the compositions and how they affect the transformation behavior and the metallurgical results, and therefore the mechanical properties. We've gone a long way down this road with flat rolled steel, and we are just really beginning to scratch the surface for the long products. But they will happen. There are mills being put in that'll take advantage of this kind of information and the alloying you can do here, and this will greatly reduce the cost of long products, the leaner steels that are are possible, the strengths that you'll be able to obtain. So we are really only just beginning with this. This, of course, will have implications for the general galvanizer. The general galvanizer will need to understand this sort of information if he is to successfully process these steels and to come up with the mechanical properties that the customer requires. An example of this is the QST process, and this shows here a typical H-beam rolling process. The left-hand side is the finishing stand, the last stage of rolling for an H-beam, a typical structural beam. And then it comes out of that at the yellow temperature, which is 850 degrees, and then goes through this QST cooling bank, which you see in the middle, which is a quenching. You can see the quenching sprays on that yellow H in the middle picture there. And it comes out at 600 degrees, after which point it self-tempers as it cools down to room temperature. This process is now used in North America. It's being used in Europe a little bit, but you are going to begin to see these QST types of beams coming in for hot dip galvanizing. This process is growing. There's more lines that are using these, and so these are leaner steels. We'll have to understand how the galvanizing process affects the mechanical properties of these, because actually galvanizing is even more of a or it's an imposed tempering that'll be put on there at 460 degrees, of course, with the zinc dipping. This is all news to come. I gave a review paper of this at the Intergalva conference in Paris back in 2012. That's available from EGGA, or I'm happy to send that to you if you'd like to review that. So what this has done is mean that the steel makers are able to reduce the carbon equivalent, that is the typical formula for carbon and the other carbide formers. And you can see, whereas in the old days, using the controlled rolling process, and even before that, we were able to use, we were required to put much richer compositions in to obtain the 355 grade. With the QST process, you can see the stair-step shape has dropped. We're no longer starting off at 0.35, we're starting off at 0.2 on the y-axis, and then we stair-step up even slower, because we're taking advantage of the metallurgical transformation behavior rather than relying upon the compositions that are shown here. This really shows how we've been able to make the steels lean if we do this. So this is coming, and we could expect this is going to require a increased knowledge of this by the general galvanizer. So if you look at strip, long, and flat products, we can see that this is complicated by the non-uniformity of section thickness for beams. We have heavier section thicknesses, but people are learning how to do this. These are things that are the knowledge is being developed right now. They require higher rolling forces by the rolling mills. People are putting in more powerful rolling mills to do this, and the holding times are going to be quite long. In many cases, they may not save the money on the lean alloys. It depends upon the price of metals then, how it all works out. So thermomechanical processing combined with alloying together is what is going to be required in some cases. So these different techniques can be used, and we did a project on this. The Intergalva paper talks about it. And we don't think overall there's going to be any problems for the galvanizer. We think the issues that are going to come up from doing these steels during hot dip galvanizing will be possible for you to handle. We'll have to be aware of the fact that they are there, but it'll be on the order of the reactive steels problem that came up with continuous casting many years ago. These are just more things that we'll have to learn to adapt to and control to maintain a successful product. We also finished recently a project on the design recommendations for K-joints. And of course, a K-joint is a tubular steel design, sometimes with a shaped square tube, which is welded together. And it's very, very common in structural work. You see it all the time. And what happens, of course, is to hot dip galvanize, we put in drain holes and vents. And you can see these are the marked little black squares that you see. This is typical venting design for a structure like this, where you'd have hollow tubes joined together in this so-called K-joint design. So we've studied this. We did a project at the University of Cantabria in Spain. They made an apparatus that looked like this. We were able to pressurize it with the cylinder that's shown in the vertical axis there, and to determine what the point of failure was when we stressed these beams. We also did, this is just the actual picture of it, showing the loading of these, and this has the venting holes in the right places. But we then show the buckling. You can see actually the buckling in the samples here if you look carefully at the vertical beam there with the gridded positions on it to measure deformation. And we did this both with black and also hot-dip galvanized structures to determine the effects of galvanizing on the buckling loads for these K-joints with the vent holes in the usual places. What we found out was that the K-joints were not affected by galvanizing or by vent holes. You can see that the buckling always occurred away from the vent hole. The vent holes in their usual places do not influence the mechanical strength of these K-joints. As long as we put the vent holes down near the welds, the buckling will occur away from it. So this is good news for the designers who worry that if you put in vent holes, you're going to weaken the joints. And you actually don't weaken the joints at all because the failure occurs elsewhere. So another program that was recently concluded was the effect of galvanizing on the fatigue strength of structural beams. And this was presented at the EGGA conference last year, 1 year ago in 2013, because to get a galvanized beam specification for bridges in Germany, of course, they needed to show what the effect of galvanizing on the fatigue strength of those galvanized beams would be. And as it said here, hot-dip galvanized structurals could not be used in bridges until recently because only non-galvanized details were covered in bridge construction. And so a number of fatigue curves, the typical stress versus fatigue life or SN curves were generated, and we showed that this quantified the effect of hot-dip galvanizing on fatigue strength for quite a number of steel grades that are used in bridge beams. And as a result of that, we did both these large and small scale tests and really didn't find any big change to what we already knew from the literature. And we now have in the German specification hot-dip galvanized beams for bridges. And the only thing that you really need to worry about is you have to lower the detail by one detail class or category to compensate for the lowering of fatigue strength, the minor lowering of fatigue strength. You drop it one detail category on your SN curve, and you are allowed to use it at that point. So that is very good news, and we want to bring this information to other countries to be sure that we can develop the galvanized bridge beam market there as well. So what we find, okay, this is just about the K-joints. I got this mixed up, so we'll go on. The last topic is on the galvanized reinforcing bar for concrete. We see increasing use of this in Australia, China, Japan, and North America. There's really two products. The first is the traditional general galvanizing, and the second I'll be talking about tomorrow, which is the continuous galvanized rebar galvanizing, which is a much lower cost continuous process for rebar galvanizing. So there's been some very good projects recently. The Deepwater Ocean Outfall in Sydney, Australia is a large pipe galvanized concrete pipe with galvanized rebar inside, and so that was chosen for its very good durability. We've seen galvanized rebar used for more than 40 years in marine structures. It shows on a North Sea oil platform, and this has a lot of galvanized rebar in it to improve its corrosion resistance. The cost of galvanizing was 12.12% of the total project cost, and then they have all that additional corrosion protection. So other galvanized rebar projects, we have another ocean outfall system in Singapore. This is a 5-kilometer concrete pipe system which used galvanized rebar in it. Each of the concrete pipe sections was 3 meters in diameter, 8 meters in length, and contained 7 to 8 tons of galvanized rebar. The Florida Keys Bridge off the south coast of Florida has been around for many years, and they have used galvanized rebar in the bridge decks and the substructures. So that is providing corrosion resistance to the structure of that bridge link. Just a word about old versus new zinc. I was asked to say a few words about this. We sometimes see zinc that's been sitting around for a while and it has oxidized or it's soil adherence on the outside, but those are only ppm levels of the overall weight of the ingot. We had a hurricane in the USA, Hurricane Katrina, back in 1985. It flooded the LME warehouse there. There's millions of tons of zinc that's been recovered from warehouses like that just by washing, and that allows the full metallic value to be realized. Once we do that, there's no real difference between old zinc and new zinc. So just to conclude now, in the last few minutes, we have a few case studies from around the world. This is the first one is from the Pacific Ocean. This is the Marshall Islands, which is a U.S. possession where we have a military base. And there was a military fuel pier that had been there for a long time and had deteriorated. So it was replaced, and they required a 75-year service life for that. And also it was a dock, a wharf sitting out in the water. It required 15 tons of load capacity, and it sat just above the water with a very low tidal change over time. So at that point, they wanted to have it 100% galvanized. So this was entirely assembled on the U.S. mainland, and everything was put together to check the fits and then disassembled and transported to the island. So it is a concrete deck with galvanized rebar sitting just over the water, and it has been designed for a 75-year life. This is a horse stall in Florida. And this is an open-air building. This is a large racetrack, so there are 380 horse stalls in it. And you wanted to have a tough coating because the horse rubs against the side of the stall, and so it's a bit of an abrasive situation, and all kinds of tack is hung on it. And this was able to meet the project deadline. The galvanizer got all the steel dipped and delivered. There was no weather delays, of course, since he's inside the galvanizing plant. You don't have to worry about painting outside. And the metallic finish, this just shows that you can have an aesthetically pleasing bare galvanized structure and these kinds of things. And also, of course, we know, we've heard about today, zinc is healthy. If zinc would chip off in the very small amounts, that if the animal rubbed it off, it would not affect the animal. Zinc is already in the animals' diets. The zinc's probably eating, the animals are probably eating better than many people with their zinc nutrition, and you don't have any chip or flake problems coming from the paint. This is an infrastructure project. This is the rebuilding of a road down in the Bordeaux area of France, moving down to the southeast coast. And France is privatizing its toll roads. They've granted concessions to a number of private companies. This was a 40-year concession for a company to take over this road and put tolls on it. So it's a 105-kilometer-long toll road now. And the operator of the road, of course, wanted to have a maintenance-free life. They don't want to spend much money on maintenance. They want to collect the tolls and make a profit. So they've rebuilt this road with galvanized guardrails and other street furniture. So this will last for at least the 40-year life of the concession of the toll road operator. So this required 7,500 tons of all kinds of galvanized steel, including 370 kilometers of galvanized guardrail. So this road has now been greatly enhanced. Its capacity has been improved, and the safety has been improved, and it's got a lot of galvanized steel on it. So in Germany, this just shows an example of a bus station. This was formerly a rather unorganized sort of bus station situation, and now they've turned it into a transportation hub. This shows like a ring held up above. So the ring provides weather protection for the passengers. It allows light in, and the play of light on this is very interesting. It uses an expanded metal mesh, which has lights contained in it for nighttime, but the light comes through it during the daytime. We heard a bit about that with the airports. It is possible to make these things look very pleasing in appearance just by using them as uncoated galvanized steel. Again, this was put together in a prefabricated situation with the galvanizer. It was just put together with screws when it was transported to the site, and a variety of seating possibilities are all there. So this bus station is a very nice case study. And in Spain, this is a little football stadium. And unfortunately, Spain did not do so well in Brazil, but we still we see here a little football stadium they built, and this had to go between the football pitch and the track. It was one of these little spaces they wanted to use. They didn't want to impinge on the track on one side or the football pitch on the other, so it's only 3.8 meters wide, and they were able to put 5 rows of seats in there. So the floor, the walls, the roof, and the supports are all galvanized steel that was put together again with bolts, 240 bolted connections, to make a very nice looking stadium for the football pitch. So this is the UK Galvanizing Awards were just announced last week, so this is very new. There's several winners, and this was the one in the category for engineering structure. There's a number of other structures and winners, and I refer you to the UK Galvanizers Association site, which is all the winners posted there just last week. This is a biomass fuel storage building, and this brings in biomass from other parts of the world, because now in UK as well as other European countries, a certain fraction of electric power is required to be obtained from combustion of biomass. So it's imported. It comes in off the Irish Sea, and where this port is, and so this structure is 1,200 tons of galvanized steel, and it can hold 65,000 tons of wood pellets coming from forests or other biomass that come in there. So it's 4 meters high, and it has the angle of the roof is equal to the angle of repose that you get when you pile up wood chips. So this makes for a very efficient storage. So when you pile up the wood chips, you're going to naturally get this 39-degree angle of the pile of biomass, and that's how it was done. And then what they did with the overall frame was to clad it in PVC. This was not for aesthetic reasons, but this was because of the fact that it's within 150 meters of the sea. So in conclusion, our final slide here, we see that galvanizing is not just the coating of steel, but it is a complete service. We need to grow our market. We need to find ways of working with customers on quality, on logistics, and providing expertise in design. We have here in our collective group, and also with your associations, the expertise to allow for helping with these problems and for helping with design. We see the second point is the new steels are coming, and we can see there's going to be leaner steels. We know the customers want lighter, stronger, cheaper, so that will be driving that new development. We have new standards that are being developed for coating weight. We also, I didn't talk about it here, but the eco policies, the life cycle policies, the environmental product declarations. Steve Wilkinson mentioned this morning about the Zinc for Life program, which has developed many of those, and also the need to train our personnel. IZA has an interactive training tool, which is available on the internet if you wish to take advantage of that. I'm happy to tell you more about that. So with that, I'll close. That's really our overview of the global hot-dip galvanized market and technology trends. Thank you very much.
Thank you, Frank. That was an excellent overview on the technology and market trends worldwide. Plenty of country-specific data, successful case studies of galvanized rebar in many countries, and the international case studies. Yeah, mine of information there. Maybe you may have some questions later. Now let me turn to Kenneth De Souza. He's going to be talking about sheet galvanizing. Again, technology and market trends globally. Ken.
Thank you, Mr. Chairman. I really must take my hat off to all you people who have stayed so long, and you still look like you're attentive, so congratulations. Give yourself a hand. So just for the few of you that may have wondered what Frank was talking about, he was talking about general galvanizing, what we call in our neck of the woods, post-fabrication or after-fabrication galvanized. What I'm going to be focused on is sheet galvanizing, so everything that's produced on a continuous galvanizing line. All right, so just so that you know where this is. Now, I must admit, I haven't made as much of a study of this as Frank has, and so my global market, and certainly on the technology trends I've got a good handle on, but on the global market size, I've struggled a bit to get information, and I told that to Andrew and to Mr. Kulkarni as well, that I need help in that area. Having said that, let's see what we've got. Okay. So what I'm going to focus on is just some global regions and the market sectors that typical continuous galvanizing line product enters and is used. I'm going to talk a little bit about the key market and regulatory drivers that force us into some of the product decisions and processes that we use. We'll talk about some process technology trends, and then a subject very near to my heart, which is product technology trends. And then we'll try and look a little bit into the future and see what kind of products are coming down the road. All right? So I went to the World Steel Association website and downloaded their big report. And then I did some selective data collection on the four areas that I chose were the Americas. So North and South America I combined. South America is a really small part of this, maybe 500,000 tons total. So it really didn't make sense to put them out as a separate region. So I combined the two Americas, made it, just called it the Americas. Asia, the red line, that's the giant and the big elephant in the room. So that's really the one we want to focus on, being in India and all. Europe, the European Union, I took the data that was basically talking about the EU 28. So there's a group of Western and Eastern Europe combined. And then the rest of the world, which seems to just putz along, with really no change over the years that I've got on this graph. So those are the four areas. Now, if you look at Europe and the Americas, you'll see that they've always been sort of close to each other. Europe suffered like the U.S. did, but maybe from a galvanizing standpoint, the North America and South America really suffered the 2009, the global meltdown on the financial markets, and that took down with it a lot of the manufacturing. But the good news is that North America and South America is starting to recover, and it's more or less back to where it was pre-recession days. Europe, on the other hand, has continued to suffer, and although they've kind of flatlined, there is hope that it will start to uptick a little bit, although the uptick is not going to amount to very much. But here's where the good news is for India. And I've got to tell you that in 2013, in India, we made 5.9 million tons of hot-dip galvanized on CGLs. And when you look at the total for Asia, it's almost 60 million tons. So you can see that most of that is China. They produce about 9 times more hot-dip galvanized sheet than India does. So that's really what's driving the global production of metallic coated sheet steel. So then you look at where does all this product go into, and I've again used the 3 of the 4 regions, because the rest of the world really there's not enough product in there to really spend time talking about. But in Asia, and you'll notice this, for those of you who are analyticals in the room, you'll notice that the numbers don't always add up to 100%. And that's true. If you found that out, again, pat yourself on the back. So in China, for example, of the 60 million tons or 54 million tons they produce, only 15% goes into the auto sector, which tells you something, that the auto sector is really, they're like India. They're not really fully galvanized in their body panels on cars and light trucks. So there's an opportunity in China, and I think we've heard enough over the course of the day to show us that if China starts to implement coated steel in its automobiles, I think it'll help the Indian cause, because we're going to follow in that direction as well. Most of the stuff, metallic coated sheet steel that's produced in China goes into the construction market. And then the appliance market in China is also quite significant. So the balance is basically tubular and a whole host of miscellaneous other market segments. Now in Japan, it's a completely different story. Japan produces probably the most sophisticated grades of steel in the world. I mean, certainly more than Europe and North America in terms of just, different qualities of steel and advanced high-strength steels and so on. North America and Europe are catching up, but you can see that Japan is using 55% of what it produces goes into the auto sector, because they really have developed this technology to a unique level. The construction market shipments of CGL type produced product is only 16%. 4% is in the appliance sector, and then the rest is, again, tubular and some miscellaneous stuff. India's story is actually quite different. So although you have Asia, China, Japan, India, you can see the automotive utilization of sheet galvanized is so different in each of these countries. In India, we think it's about 9%. Construction, 26%, appliance, 9%. A big tubular section in India, it's about 18%, I think, tubular. And then the balance is export. So, this is where our product, or the metallic coated sheet produced on CGLs is going. Just to compare, the Americas auto is just over a quarter of the production. Construction is the big thing. 40% is construction. Again, we're talking only sheet galvanizing here. Appliance is 4%. Tubular is, again, a very significant number in North America. And then the balance. In terms of Europe, the EU 28, automotive is, again, a big number. It's been stable at that number for a bit. Construction is 24%. Tubes is 18%. And appliance. So this is where the product goes. So when I got involved with IZA after I retired from almost a 40-year career in the steelmaking end of things, Steve Wilkinson asked me if I would be interested in sort of looking at the Indian market. And when I did a little bit of digging and research, I came across the slide that Hindustan Zinc had brought to my attention. I said, this is going to be a piece of cake, because look where we're starting from a standpoint of whether it's zinc utilization per capita. I mean, it's bottom of the chart there, so there's only one way up, and that's, growth. The same with the market. There's a huge opportunity in India that is yet to be tapped. And then to my bad luck, the last 2 years, we know what happened to GDP in India, so things stagnated and the economy sort of flatlined and actually declined. So, it's a great situation to be in, trying to grow the Indian market for galvanized sheet. A high growth, high demand market, and the lowest per capita utilization in terms of zinc. So we're really looking forward now that things are looking up. We have a stable government, as people said. And I think the reins of red tape are going to be unleashed, and the growth is going to really take India where it needs to go. So let's look a little bit at regulatory drivers that affect our markets. And I'll go over some of the major ones by region. But here in North America, what's driving our decision-making on just about everything in terms of products? And there's no question that it's CAFE, or corporate average fuel economy. So the graph on the top shows, from the inception of CAFE in the 70s to where it's headed for in 2025. And you'll see the Obama administration standards. And I don't believe personally they'll get to 54.5 mpg fleet-wide average, but certainly that's the goal. And you can see where we are, and we've got a long way to go. So those CAFE standards are really the big driver on this. On top of that, you've got increasing safety standards that are now the law. So not only front impact, but also side impact is a huge thing, and the penalties, I believe, are very, very, very severe if you don't meet those.